Okay, hey everybody, this is Andrew over at Design Point. I'm here today with Rusty Renkel, one of our favorite customers, and he is absolutely the definition of a power user. He uses the software in ways that are amazing, frustrating, breaking everything in sight, and we love him to death as part of the Design Point team. I wanted to invite him today. He graciously took some time out of his schedule to take a couple of examples out of what he's done for his company, Pentech, and he's going to share those with us primarily in maybe the electronics world. But we're going to get to see an insight into some of the things that he's designed. So, hey, Rusty, how you doing?
Great, Andrew. Yourself?
Good. Hey, Rusty, what's your job? What's your company and what's your job title there?
Okay, the company is Pentech Incorporated. My job is I'm a senior mechanical engineer here, largely doing electronic packaging, thermal analysis of same.
Okay. And how long have you been using SolidWorks?
Since 1996.
Didn't it come out in like 95 or something like that?
Uh-huh.
Yeah. So you're
That's correct.
pretty experienced. Okay, great. So
I mean, in between, there were a couple of instances of using some competitive products, but
oh,
that's when I first started using it,
we're
and
all
by and large,
yeah, the 90s, we all want to forget that. We're good. I'm glad.
yep.
Okay, now Rusty. So today you've got two different examples. This first one, what are we looking at?
So this is a shield housing for some electronic RF sections on a printed circuit board to isolate the magnetics so that they don't interfere with one another. If we explode this, you can see that there's 1, 2, 3, 4, 5, 6, 7 dividers
Mm-hmm.
sitting in here that give us 8 sections.
Mm-hmm.
And so, these are spot welded into this frame, and then the lid drops down on top of that, and these longer fingers get actually installed into the printed circuit board and soldered fast there.
Wow.
The top comes off so that we can do any tuning that we have to down with the electronics, and then once the lid is put back on at final assembly, we simply go in and bend the tabs over
Mm-hmm.
so that it's locked in place.
Wow.
And if they are in their vertical orientation, again,
Mm-hmm. Wow.
the user can go ahead and take this thing. Let's see if we just float that for a moment. And so typically, this lower section with these things spot welded in place
Mm-hmm.
would be soldered to the board. Once it came out of the whatever secondary operations had to be done,
Yeah.
this lid then would be put back down in place.
Wow. Okay, so what was it like to design this in SolidWorks?
By and large, this actually is fairly straightforward. This is all fundamentally straightforward sheet metal pieces.
Okay. So you use sheet metal. What size is this, by the way? Is this, what are we talking about?
This is about 2 inches by approximately 1 inch.
Okay.
By about 1/4 of an inch high.
This is a fairly big device then. Okay. Yeah.
Well, for reference for you, I will show you the assembly that it goes on to.
Okay.
And you can see there's actually 2 of these that sit side by side.
Oh, wow.
Back here.
Wonderful.
And if we hide the lid, you can see some of the electronics that are sitting down in there.
Okay.
These, if I had them in detail mode, these are actually coils that are very fine.
Right.
And were being damaged in handling. And so that was, besides the RF EMI magnetic emissions separation, this is also serving as a protective cover over these for handling and installation and whatnot.
That's amazing. Can we go back to the sheet metal part, the one that was kind of like the frame that you had open for a second. Okay, let's talk about this guy for just a second. There's some really cool things going on here. So is this one sheet metal part, or is there multiple?
This is one sheet metal part. And if we can, yeah, okay.
Yeah, it's always the fun part. So, okay, so this guy is put together this way. Talk about some of the tools that you use to create this, because I see some cool things going on.
So we've got dimples. So that lid, when it drops down over those tabs,
yeah,
the lid also had some cutouts in it that actually snap over these dimples. So that's the first level retention, as well as the tabs coming up through the top, and then the tabs being bent over is the second securing of locking this in place so that it can't come off.
How'd you make those dimples?
That was with forming a small forming tool and locating them and then embedding them.
Now, did you design that forming tool?
Yes.
Okay, so you designed a forming tool from scratch. You knew it could be manufactured, and then you applied it on the surface there, and it bent both sides of the sheet metal part.
Correct. And it, in fairness, completeness, I was working closely with the vendor that actually manufactures this for us.
Oh, okay.
And we were trying to align this with some of their standard tooling.
Nice.
So they told me what size dimpling they were using, and then I went ahead and made the dimple tools and located. So. And
so you've saved that dimple tool into your design library.
Yes.
Okay, so you could use that all over again. Okay.
Correct.
It seems small, but this is a fascinating way to start this off. I mean, and then what are all the axes that I see in your design tree? What are you doing with all those?
So this was partially location of the individual dimples.
Oh, cool.
So that, helping in placement of those.
Wow. Okay, gotcha. So if anything ever needed to change, you could just update it and that would all kind of form to the right place.
Correct. Yep.
Fantastic. Well, so this is just a simple thing. So you use sheet metal, even though what metal is this again? Is this copper?
This is actually a tin silver tin.
Silver tin.
They call it.
Wow. Okay.
Yeah.
And even at the small scale, so you might not think of sheet metal like you most of the time you might think of sheet metal as like a big, covering for a motor casing or something like that. But you used it all the way. So I said that this piece was big, but that's only in terms of the electronic side of things of what I know you work with. But as far as sheet metal, this is one of the smallest sheet metal parts that I've ever seen, I think.
There you go, 1.948 in length. And
did you have to create a new material for the tin silver in order to use it at this kind of size or thickness?
No, I actually assigned that because originally I thought it was going to be a beryllium copper material. And like I said, in working with the vendor, he changed it and the densities weren't that different. So I didn't update the material, which I was using for weight.
Yeah.
A lot of times we'll take the weight out of our assemblies and use that as first order in, documentation or brochures or pamphlets that we're putting together on the products. And then, once we've got a final product in our hands, we can weigh it and update it if necessary.
That sounds perfect. Yeah, you're a power user, Rusty. You get to kind of fudge things. You already know what's close, but you had it in the right ballpark. That sounds good to me. Is there anything else that you wanted to show on this model?
No, I mean, the rest of it, you've seen the tabs bend up and down. That was just a feature that we put in so that we could make sure of all the clearances in the upper level assembly that this goes into.
Okay.
And no, we can move over to the other one.
This other one's really cool.
And I guess maybe
once I'm excited about this one. All right.
I guess I can say. So this is another printed circuit board assembly.
Okay.
And these RF connectors at the front, typically in another style of our boards, would come out through a faceplate here in the front.
Okay.
Along this edge. But due to a new standard that's evolving, we needed the ability to take those signals. These are all RF coax signals that we're taking back into a connector block at the rear of the board that then plugs into a backplane in a system.
Okay.
And so we had to figure out how to route these 19 cables from the front back into these connectors. And the other thing that we had to do was create the paths. So let's see if I can get this to, I think this is the right one.
Okay.
Any day now, guys. Okay. So this lid, right, we had a small cut in here to begin with, and we routed the cables. And once we had the cables routed, we came back, and if I hide one or two of those, you can actually see that we used the pathway of the cables in order to create the routed path to help guide the cables across the span. And likewise, we did the same thing in the lid.
Oh my gosh. Okay, so how did you create those grooves?
Literally, I took a lift out of the cable spline.
Yeah.
And let's see if I can switch that over. That's just open one because I don't have it.
Yeah, sure. Let's see it.
The whole assembly right now.
Okay, so this is the amorphous line. Okay.
Yeah. And if we go to the, I should get it here. And I guess maybe if we go over here and we turn SolidWorks routing on, we might get some of the additional features I'm looking for. But there's a center spline that goes in this.
Okay.
And so if I go back to the assembly, I use that spline to then put a profile on it and extrude a cut that followed that path from this front location to the rear location.
Oh, wow.
And likewise did the same thing on the lid.
Yeah.
So that guides that all down in place there.
Okay.
The other interesting part of this,
yeah,
folks, I don't know whether everybody is using cabling or not, but right, you pull these out of a cable library and you got to drag the connectors and drop them, and then you can route the cable.
Yeah.
From end to end. But a lot of times in these kind of instances, you want to kind of guide the cable in a direction to where you want it to go. But in order to do that, you need something to kind of route through.
Okay.
So, I've created these small virtual routing clips.
Okay. And
it doesn't look like much, but it does a huge job in the cable assembly.
Really?
When this opens up, I'll show you the small tree of features that are associated with it.
Okay, so this is something that this is a power user super trick. So this is something that wasn't part of the normal idea of how to use routing, but in the real world, you knew that this concept was viable, right?
Yes.
Okay. I see. So, whoa. Okay.
So this gets mated into some assembly-only holes that I put into the assembly just for these virtual clips. And so you've got your alignment on the axis, but then we put an alignment of a plane against the surface where we could put these on various angles. And you can see the angles are going from, 10 degrees down through, 25, 27, 32, 35,
get it.
And down to 7.5.
Oh,
and depending on exactly which location you're in the assembly, you have to orient the clip different in order to get the cable routed in the direction that you want it to go.
Yep. So you can click on it and switch the configuration almost like you were rotating a dial. You were like, oh, I'm at the 27.5 degree, but I could simply change this to 5 degrees counterclockwise. And then he's going to rotate, and then that would also change because it has the C path in it. So the route would also try and follow through that tunnel that is created, right?
And there you go. There's the update of the position.
Wow.
And yes, now if we turn the cable back on, the cable will try to reroute back through this in this orientation.
Wow.
The ones that went up here, wasn't a big deal because it was in the flat, but it's the same component and just using it at a default angle. So that same clip was used at, you know, 1 location, 2 locations, 3 locations in order to get us a pathway that we could route cleanly through.
Wow.
The other piece that was kind of interesting,
yeah,
if I hide this, is we have a connector that wound up having to sit down here on the board. And we investigated routing that coming from here back,
yeah,
or coming from here forward and back along the thing.
yeah.
The one going from here back became an assembly issue.
Okay.
Putting this one on allowed us a more straightforward assembly process, so we opted to go with the one that is the brownish gold color here on the screen.
Oh, so those are 2 different options. Those were pathways where it's like, which one's going to be better? And the one you landed on, okay, I see. They're over. So that last end terminal point is a double. It's basically 2 options ending at the same place. Oh, okay. And
correct.
So you just decided to, and it looks nice too, by the way, the one that you chose. But how was it to try and get that kind of acute angle to have it bend back on itself? What was that like?
Well, that's where the importance of those virtual clips became very clear.
Yep.
Because it was a lot of tuning of the angles to get it where we could get, you know, and the bend radius of the cable, right? When you create the cable in the cable routing module, you assign the bend radius to the cable. And, you know, this has the assigned cable radius from the cable manufacturer. And so this was getting it to a point where we could get, with the right angles of the clips, get it in there and around to the piece.
Wow. Yeah, everything works until there's a slight tweak that makes you have to bend over backwards to try and fix it, huh?
Yes. And the other part of it that was mildly challenging, was, you know, when all the cables got back here to the back end, and now they had to be routed into their specific endpoints, and clearing all of the existing hardware and making sure that they could be routed into place. So
now this
was fun and challenging.
This is a good, challenging, very, very detail-oriented task. Final question about this. Didn't you have something very cool where, like, you could also obtain the wire lengths, like they're very precise? Isn't that something that would be a difference maker for you?
Yes, and let's see if we can get one of our wires here and get a. Do I have the numbers on any of them? Bear with me for just a moment, Andrew.
Totally fine. All right. So while he's doing that, so a lot of our customers use routing in inventive ways. Whether you're putting some actual cables on your integrated circuit board, like what we're seeing here with our friend Rusty Renkel, or some of the pipe routing connectors. I've seen some different people that are dropping in components, elbows, filters, different things like that. I think it's really fascinating to see that the design of these 3D shapes. There's something where everything, it's like a pool noodle, man. Like what he has here, what he's engineered. And pro tip, you know, you can use as well, is that kind of virtual clip to kind of guide the process as it snakes through the design. I know that that's one of the toughest things that I've had to help people with. Never easy to go into the 3D realm. If you could stay in the 2D, which we all wish we could, that would be great. But SolidWorks is definitely the tool that you want to use for something like this, where you need to get a little bit more complex.
So all of that said, you know, ultimately you do wind up back in the 2D because you've got to tell the vendor how long is it,
right,
and what parts make it up.
Right.
And so, you know, we created the bill of materials off of the models in the drawing.
Yep.
And assigned the length for the various cables, and came up with a way of flattening them and putting all of them. There's there were a total of 19 different cable lengths.
Right.
After we went through and looked at them, we sorted that down and finally got down to about 11 different lengths.
Okay. That's nice.
We were able to, give it a little bit of flex, or give a little bit of extra room at the back end of it where we've got a little bit of wiggle room. So there's the documentation.
That's almost harder. I mean, it saves you time with the ordering process, but you had to go back into the model and lengthen certain ones to make it a little bit flexible and fit that extra length in the model.
Right.
Wow, that's super cool.
Do
you have anything more to show, Rusty, with the cable lengths, or are you good?
I'm good, I think, Andrew.
Okay, great. So this overall piece, this was something that probably took you a bit of time, but the using the spline to cut out from multiple different pieces. Did you work with that in an assembly?
I did.
Okay, so it was a little bit of in-context modeling that you were doing. Cool.
We did the in-context modeling and then went back and broke the in-context links and linked it directly to the model so that we don't have any, follow-on issues with it.
Oh, I get it. Okay. Yeah. So you don't want it talking too much. You want to get it to the right place, break it, and then move on and have it linked to the just the content that you need later, right?
Correct.
Okay. So this piece, so the first one was sheet metal at the inches level, and something that people might not think about, and using even forming tools with very thin materials. And then I've seen you and worked with you before. You are a routing master. So this was a little bit of a master class on how to use routing in a 3D, very unique. Each one of those lengths of wire are unique, if not, they would have been had you not moved them. And then the masterclass is really that virtual clip. So final question about that virtual clip. That's not reproduced in the real world. That's actually just only in SolidWorks as a guide for these wires.
That's correct, Andrew.
Wow. Okay.
Yeah, it simplified and enabled us to get a route from where we knew the cable would have to be in order to get to the endpoints.
Yep.
And if you don't have something to route through, it becomes very difficult with the cabling. So I've used the virtual routing clip a lot in some of these different assemblies I've worked on. That's
super cool. So Rusty, you are an engineer who's been working with SolidWorks since 1996. You're up in the northern part of New Jersey, right? What part of New Jersey is Pentec?
Upper Saddle River.
Upper Saddle River. The last power user was more mid-level. I don't know, New Jersey. I'm from Ohio. But we really love having you call in and trying to work with you on any of your technical support issues or anything that you want to talk over. You are a power user to the extreme, but we love the fact that you want our help in working through all your design. So I just want to say that this was fascinating to see. I really appreciate your time. Is there anything else you want to say to anybody out there with, SolidWorks or anybody other, the users out there for advice working with the program?
Big shout out to Design Point's application engineers. As Andrew indicated, I'm not afraid to pick the phone up. I've used the program for a long time, but there's so many features and capabilities in the tool that it's hard to know all of them. I do touch on almost all of them. I do solid modeling, I do sheet metal, I do cable routing, I do thermal simulation. It's a lot of different features and tools to touch. We've used the visualization tool to make some mock-ups for marketing and sales initially. So, don't be afraid to reach out to them. They're a good resource. And, Andrew, thanks a lot to you guys for the support that you've given me on some of these projects.
Well, thank you, Rusty. Yeah, I grow from every single time I talk to you. All right, everybody, thanks for joining us. This was some masterclass routing. We'll continue to do this. If you want to be interviewed for power users, just give us a shout at support@designpoint.com. And until next time, I'll see you guys around.